This meeting is being recorded.
In this next video, we'll take a look at the next section from our Chapter 15 Chemical Equilibrium worksheet. And there's some mention here that the concentrations of solids and liquids are pretty much constant when we consider equilibrium reactions. The only reagents that change in concentration would be aqueous or gas. So again, liquid, so anything designated with an L, anything designated with an S, we can pretty much ignore, and they would not appear in an equilibrium expression. So let's take a look right here, and we'll get some examples of that, and then we'll take a look at sample exercise 8. So the Kc expression for this equilibrium of this lead fluoride here, we're going to not even include that solid, and our Kc would just be products over reactants. So since there are no reactants, it would just look like this. And since this has a 2 as a coefficient, we need to make sure to incorporate that as an exponent. So Pb2 plus, and then times the concentration of Cl negative squared. For this second example here, again, we're going to ignore the solid here, but notice that there's also a product solid, so that will be ignored. So our Kc for this expression here, for this reaction, is really simple. And we could just say the concentration of CO2 is the only thing that affects it. So there's 2 examples. And we're given some additional information here to note that as long as some of this calcium carbonate or some of this calcium oxide solid remain in the system, the amount of CO2 will also remain the same because, none of this is decreasing, so we're not shifting either way. So let's take a look at sample exercise 8 here. And we're asked to write the equilibrium constants for these examples here, for these 2 equations. So in the first equation, we have gas, 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 liquid. So if you recall, liquids remain constant. They will not appear in our overall Kc expressions here. So let's look at our product. We're going to put the concentration of CO gas on top, and then we're going to divide by our CO2 concentration and H2 gas. So this is for part A, the Kc expression over here. Let's take a look at part B, and notice we have a solid. Oh, we also have another solid over there. So our Kc expression here will just be our single product on top. But remember, we have to square that because of the coefficient 2. So CO2 squared divided by also CO squared again. So just remember that whenever you have a coefficient, that will become an exponent in your equilibrium constant expressions.